today is NASA, ISRO. They did several missions, but alone. This is the first time together they are going for a common mission, and the mission name is the NISAR. In this video, I'm going to talk about NISAR, and as you see here, the way satellite moves around the Earth, the way satellite moves around the Earth, the way ISS moves around the Earth. We want to rotate the radar of Earth in the space with a satellite in the similar way, and that's why we are going to this mission in order to track the Earth and Earth-based phenomena. Right, and this mission is going to launch this year. If you want to explore every minute details about the NISAR, let's watch this video. And now I'm going to give you every details about the NISAR. So first of all, understand what is NISAR. NISAR stands for NASA-ISRO Synthetic Aperture Radar. In other words, you can say NISAR is satellite-based radar or a dual frequency imaging radar satellite that are capable of penetrating the cloud and the atmosphere of Earth and collecting data throughout day and night in order to give you every minute details about Earth and Earth-based event. Now, what is the contribution of NASA and ISRO in assembling this radar-based imaging satellite? So NASA contributed for their own benefit, ISRO contributed for their own benefit. So first of all, I'm going to talk about the NASA contribution. NASA provided L-band radar. Along with that, NASA provided their GPS system and solid recorder to collect or record data in order to get benefited by getting information about clear air turbulence studies as well as for global science operations. Now, what is the contribution of ISRO? ISRO contributed by S-band radar system, their GSLV launch vehicles. This S-band radar system work on the wavelength of 5 to 15 centimeters at the frequency of up to 2 gigahertz and help in near and far range weather observation. What is the purpose of the NISAR? So the purpose of the NISAR is number one, to explore any minute changes takes place in the Earth's surface and their interiors. Second, to track the flow rate of glaciers and which ice sheet are melting, to give information about that. Next, to monitor forest as well as agriculture region and to give information about climate change. Next, to track groundwater level as well as to give information about environmental disturbance and ecological imbalances. Next, oil spills. So there are so many events that are based on Earth and their atmosphere, their surface, their interiors. So this imaging satellite give information about all these phenomena. It work day and night and penetrate atmosphere and cloud and provide us every details about all these phenomena. The main objective of this venture is to get early information about highly earthquake prone or seismically active Himalayan regions and provides us a clear map about any deformation on every 12 days. That will help us in getting early information about land subsidence, volcanic eruptions, and any seismic activity in the polar region. So this satellite will place in lower Earth orbit and it moves over the poles and especially in sun synchronous orbit. So now this is the main component of the satellite. So which component belongs to NASA and what component belongs to ISRO? Now I'm going to give you details about that. NASA contributes L-band SAR electronics, their GPS and solid recorder to store data for global science operations and for clear air turbulence studies. So this is the objective of the NASA. And now what is the contribution of ISRO? ISRO contributed the S-band radar that will provide services for 5 years, and this S-band radar operates at the wavelength of 5 to 15 centimeter at frequency of 2.4 gigahertz and help in near and far range weather observation. Along with the S-band radar, ISRO also contributed their GSLV, geosynchronous launch vehicles. By that, this satellite will place in the space